far north of Australia, which sounds cold here, but it's very hot there. Okay, so welcome to 497. What we're trying to do this semester and next semester is build something, right? And this semester we're trying to figure out what to build. The first half of the semester we're going to do what I call ideation, thinking up grand schemes that maybe we can do, and then doing a bit of investigation to figure out whether we can do them and how we can do them. And then doing what I call a down select, which means I want every individual to come up with a different idea, but then we can't do every single idea, and we'll down select to, like I said, one or maybe two ideas to move forward. Most of the, I'm going to try and not have anybody do a capstone project on their own again. I had one person do it 3 cohorts ago, and it didn't work out well. So I'm going to try and avoid that if I can. So let's see if we can avoid it. So that is the semester, and as well as these pieces of assessment, there's some other stuff that I want you to do. So and I'll talk about those. But what's in the box is some electronics, and there's a printed circuit board, right? And the printed circuit board actually has the circuit drawn on it, so it's reasonably easy to see. And then the rest of the package has all the components. So one of the things I want you to do today and next week while we're in class is to actually solder that up and have it work. Unfortunately, we don't have any power supplies, and I forgot to bring some 9-volt batteries. So we might have to finish it off next week. Anyway, I'll talk a bit more about that later. And let's see if we can.
It's very basic LED.
It's basically an A-stable multi-vibrator flip-flop with 2 transistors, and the LEDs flash on and off alternately. And there's a couple of trim pots on there, potentiometers, but you can change the rate at which they flash. The reason I'm doing this is because previously in capstone I've had people who've had to solder stuff who've never soldered before. And I want people to be able to solder. I don't care whether you're going to do the software on the project. I want you to at least have tried to solder something right out of this CET program. So, you have that? Have you? Yeah. Oh, you have?
I've never soldered, but I've watched many videos of soldering.
Okay. So that's me. Call me Peter or Professor. Hey, you works too, but that tends to attract everybody's attention, so be a bit more specific. I have a bachelor's degree as a master's in electrical engineering, and then I did a PhD in transport statistics. That's my CCSU email address. I don't have an office on campus, so we're just going to have to meet virtually outside of class. So use that link to book some time. I think at the moment I only have office hours associated with Tuesday afternoon. But if that doesn't work, just let me know and I'll arrange that. So, I was hoping to have everybody here, but let's go around the room and tell me who you are and what you're interested in from a capstone viewpoint.
So my name is Chuck. I show for our particular background. I'm a June, and what I expect what I just learned in this class is just practical hands-on experience on how to like build something. At least you guys need to think that interesting from the previous classes that I did in or something like this possible.
Okay. Julio, you want to come up?
So Julio. I'm a CET major. And then I'm really excited about this class because it's the first class I'm taking at CCSU where I'm able to build something. And I'm hoping we can build something really, cool, with maybe a smart mirror or I don't know. Are we gonna be coding as well?
Just about everything we're going to think about is going to require hardware, hardware meaning mechanical hardware, electronics, and software. Right? The smart fridge last semester had an app and code on the Raspberry Pi to work the camera and send the images. Right? So there's all sorts of stuff we have to do, and it's a lot of the projects we do are in what I call Internet of Things. Right? So there's some networking there, which you know about. There's software, which you have to connect things on the network you need to know about. And there's the electronics at some level. Different projects require different levels of electronics.
That's really cool.
So, Tanya, you want to come up and tell us?
My name is Tanya. I'm also a CET major, and I'm a senior. And what I'm looking forward to most in this class is basically applying what I've learned from all of my basically coding classes and networking classes, and making something like using the knowledge that I've learned.
Okay, very good. So, I haven't found a decent reference to talk about this stuff. So there's nothing particular. Hey, Matt! So we've just done introductions. You know me, I know you, but maybe these people don't. Can you stand up and tell us your name and what you're interested in doing maybe in capstone?
Hi guys, my name's Matt. I'm CET major. As of right now, I'm not sure what I want to do for my capstone project. That's a little summary of me, I guess.
So, I've told everybody else, but the first half of this semester is basically trying to figure out what we're going to build. And initially I want everybody to work individually on ideas, and then about halfway through we'll do a down select and either split up into two groups of two or have one big group of four and work on one project. There'll be enough work for 4 people or 2 people, but we've got to do the idea generation first. So we'll see how that goes. So what is capstone one about. So it's a little tricky, there we go. So it's about using your skills and knowledge to design a CET product that you as a team are interested in. Right? And there's all sorts of stuff we could use. I'm thinking we need to work with micros, whether they're Raspberry Pis or Arduinos or the ESP32 or any of the other micros you've worked with. Servers perhaps, PCs perhaps, working with integrated development environments to build stuff, soldering. So it's a little electronics kit I'm going to get people to try and build during class. So it's a little LED flashing circuit. I don't know whether we'll finish it today, but we'll start it today. Version control. Matt, you know all about version control, so that, I might lean on you a bit for that. I'm going to try and get you all to attempt to build a mobile app. Just a really simple one. And we need to talk about planning.
Will you be using Kotlin?
I'm more of the opinion that something like React Native using JavaScript is easier to get up and running, particularly if we have a mixture of Android and iOS devices. JavaScript is a language. A lot of it is used in websites, but React Native and Node.js can be done as mobile applications strictly using JavaScript.
What do you mean that that's what I like to do more, like just in Java, I kind of think very that easy. And I'm looking at like how familiar JavaScript would be with Java, because like prior to JavaScript we used to use the thinking was like more about it.
So a lot of the for loops and that sort of stuff are very similar to each other. But JavaScript and Java are very different languages. So particularly with inheritance, JavaScript uses an inheritance mechanism that is different from just about every other language. It uses what's called a prototype inheritance mechanism. Which is very powerful, but it's different from the way Java does inheritance or C++, for example. But we can talk about that. Like I said, I'm aiming for you to build an app during this CET497. So then when we get to next semester, the aim is to build that product, right? And using some or all of those skills. You may not have to solve it. You may not have to code the thing. Sometimes some teams like to split up the coding for one group of people and the hardware side for everybody else. Some people like to have everybody do a bit of everything. It all depends on the team and how the team works together. Right, so another way of thinking about what's happening in this class is what's often called the design Z. Right? You start up in the top left with an idea, a concept. And the next step after the concept is figuring out the requirements. And I would call those requirements shall statements. If you're trying to say what something should do, you need to say it precisely and unambiguously. So if you use verbs like may or can or should, my immediate reaction is to say, it may, but I'm not going to. It could, but I'm not going to. It should, but I'm not going to. Because if you can say no to anything, that reduces your scope. And that lets you hopefully be more successful than it's expanding your scope. But sometimes there is stuff you really, really need to do. And requirements engineering, sometimes that's called systems engineering, uses quite stilted language to say what you're doing. And that's the shall statement. The system shall use Bluetooth to communicate. The system shall be able to stream 4K video. Right? So that's the requirements piece. Once you've got the requirements piece, then you've got to make a match between what you're trying to do, those shall statements, and how you do it. Try not in the requirements. Try not to say how. In some ways, that shall statement that I just said about Bluetooth is a little bit too much about how you're going to do it rather than what you're going to do. The requirements should be about what you're going to do. It shouldn't mention if you're going to run the program in Java or JavaScript. It shouldn't mention that you're going to use a Raspberry Pi. It shouldn't mention anything about how. It should just say what either the function is or what the performance is. Once we've got the architecture, then we can start thinking about design. The architecture will have basically big block diagrams. The design, we start filling in each of those blocks. And then the detailed design, we want to possibly design a printed circuit board, possibly design the software. And so by the end of this semester, we should have pretty much nailed what the detailed design of what we're going to build is. Then next semester, we get into prototyping and detailed design. A little bit more perhaps, because it's oftentimes prototyping, actually trying to build it, changes your design. So there's a bit of iteration there. And then the last piece is going up the other side of the V, is testing it. Do we have unit tests on the software? When we connect everything up, does everything work? Does the system attempt to do what we're trying to do? Verification says, does the system meet its requirements? So we wrote the requirements up here. Did we meet, is it true that those requirements were met? Validation is a bigger issue, is did we get the requirements right? Right? We might have nailed verification, but maybe the thing we built was useless. Recently, I've been on the Connecticut website, And obviously somebody wrote a requirement for the Connecticut website that says the secure messages displayed shall be sortable by date time. And sure enough, the messages are sortable by date time. Except the date time field on the display is a text field. And it starts with the month, the day of the month, and then the time. So for example, today would be January 21st, 2022, and it would be whatever the time is, 9:59. The sorting that they do on the Connecticut website on that date time field is alphanumeric. So when you sort it, it looks first at the month. And the messages at the top are all the messages in APRIL, April. They're not in time order. They're in alphabetical order. The next messages are in August. It verifies, it sorts, but it doesn't validate, it's useless. Right? So,
Who set that up? Who did that?
I have no idea. I would never recommend them as a software house at all, ever.
Yeah.
Hmm?
Wow.
So, this is the process. Just about every engineering group, in fact, even any group that does projects has a process. And it's usually a funnel, right? So, let's go with this. So, if this is time along here, right? Usually any organisation has way more ideas than resources to implement those ideas. So what happens is up here, you have lots of ideas, but as you go through the process, you get fewer and fewer ideas. So for us, now we might have more, but I'm going to say we're going to have 4 ideas. But then about here, we're going to have to down select and come with 1 or 2 ideas, depending on how you want to work. So the phases are concept development, preliminary design, prototyping and detailed design, and then finalising the design complete. Every organisation I've ever worked in has a process something like this. It's usually more complicated than this. At United Technologies they have what they call the passport process, and it's a gated process because they have lots and lots of ideas for products, but they don't have enough engineers or resources to be able to build all of those products. So here we need in fact I should also add the functional resume. We're going to get a project relevance statement. I'm going to get each one of you individually to put together a video about your idea. And then once we down select, well, I might get you to do a written proposal for each individual idea, and then once we down select, we'll redo it for the group project. Okay, thanks. So a friend of mine, Beth Logan, she's at Roku. She's their, might have changed her title quickly, but she was the Senior Director of Data Science at Roku, the people who do the Roku devices. And this is their ideation process for data science. right? They have the idea, they do some tests in the lab, they do some small scale live tests, they do some large scale live tests, they write they write it up so that other people can use it, and then they let their customers use it. Their customers being the advertisers. And I'll see if I can try and get with a presentation for this. Let me just make a note of that. See if I can get CET497. Okay, so I'm going to give you stuff to do. Mostly, at least in 497, this is a relatively low effort course. 498, on the other hand, same number of credit points, you'll find it a lot more stressful because you actually have to get stuff working in 498, right? But there's still stuff to do, and I've actually put in some more stuff that I'm going to talk about. One of the from past semesters, one of them is the getting you to build one of these things.
And when are we going to start?
As soon as I've finished talking.
Oh, wow.
So next week, what I want you to put together, there is an assignment in Blackboard about a functional resume. Now, some of you have probably had jobs, but the idea is that you haven't had a job, but you still have skills, right? You've still got interests. So, a way to capture that when you're presenting yourself to people is using a functional resume rather than a chronological resume. So, I want you to all put together for yourself a functional resume like this. Right? I want your name, your email address. You don't have to put any other contact information if you don't want to. What you think your skills are. A 1-paragraph summary. Courses that you liked and think are relevant to what we're trying to do here. Build a CET product, and then any other interests that might be worthwhile thinking about. And they don't have to be all technical, but I've got some technical ones here, but like the teaching isn't necessarily technical. Okay. And I think that should be up in Blackboard. Let's just go to Blackboard and check. Yeah. And there should be a
Everything starts out with the functional coordinator. The with the get component and with the AD class.
yeah, that's right. So thinking about it. Very slow. There we go. I think that one's 497. There we go. So under assessment, There's the functional resume, and please use the PowerPoint template that I've provided, and please only upload the PowerPoint template. I want to be able to present this to the class next week, and I would rather have it in PowerPoint so I can do that. Okay? I need this done before the start of class next week. It shouldn't take you too long, but have a think about it. I think that should say 28 rather than 29 too. I think I got the date wrong. Yeah.
And you want a slide for each thing, subject, or kind of each,
I want one slide.
with everything on it?
Just like I showed you.
Okay.
Right? So, just like that. I only want one slide per person.
Gotcha.
And try not to make it too small, the text too small. Try to get, information up there. And sometimes the skills may not be, technical as such. Project management may be technical. Full life cycle systems engineering is technical, but it's not CET technical. Right? Quality processes aren't necessarily that technical. So have a look at that. And as Chuck noticed, there's a couple of others there. I want you to solder that circuit and take a video of it working and upload it here. There is no time limit on this. You can do it. If you do it by the end of the semester, that's good. I want you to use Git and GitHub. If you don't have an account there already, please go there and get an account and tell me what your handle is. I just have one more slide to talk about, and then we can. I only have 2 soldering irons, and I brought mine in as well. So this is the lessons learned from last capstone cohort. And one thing I want to do with this cohort is at the end of this semester, I want to order parts for that day. Because last semester, we didn't order parts until about week 3, and then we didn't get some of them until week 6, right, which is very late. Some of them came quickly, but others didn't. So I want to try and have the whole summer to have those parts arrive. And we don't have to order everything. If there's some things that we're not sure about, we don't have to order them. But the aim would be to order them at the end of the semester.
So before you were ordering them at the start of the first semester?
I was ordering them at the beginning of 498.
Yeah.
I want to order them at the end of 497. And the other thing I want to do is engage with some of the technology area. Mobile applications, Git, soldering, micros. One of the things I want you to do is use, I have some Arduinos from last semester. I want you to try and do something with the Arduino in your project. I have a couple of Raspberry Pi Zero Ws. Again, one or the other. I'd like you to try and play with them, get used to them, so that by the time you actually need to use them next semester, you've got some background. Okay, that's about all I have. I do, like I said, have a couple of soldering irons. So what I suggest you do first is see if you can, let's see if we can do this. No, it's going to be big enough. Let me see if I can take a picture of it and put it up. So there's a few problematic things with this circuit. Not many, but there's still some. Any idea what they are? Oh, so let me see if I can find it. I thought about that, but you see the trouble is all of these components are threshold components. They're really easy. I also looked at another kit. If I can figure out whether I've got it here. There we go, that one. I think it was in that one. And there's the same sort of kit, a little LED factor, but it uses surface mount devices. Right, and some of the surface mount devices are 0402s, which are tiny, like they're, where are they? Did I have it here? I don't know whether I got it here or not. There it is. There it is. Right, so this is the other kit that I was looking at using. Right, and it's a surface mount kit. And see, that's I think that's my index finger, not be that one. Right, so you can see how big that nail is. That is a resistor. That is my nail. Right, I decided that we don't have the microscopes you need in order to do these parts, or the tweezers. So I decided not to do this. I decided to use this one. In fact, that's the other thing. I can show what's in the package. Right, so there's the package, and you've got a 9-volt battery connector. You've got some 4 resistors, 2 capacitors, 2 potentiometers, 2 transistors, and 2 LEDs. Now the problems I have is knowing which way round to put the transistors. Right, we need to look up which one's the base, which one's the collector, which one's the emitter. I have problems with the LEDs, which one is the anode, which is the cathode, because they're directional, right? There's the direction there, but which way round are they? You can tell, but you need to know how to tell. And the other thing is to make sure that the Because the capacity will polarize each other. Right, so you need to make sure that you don't have them connected the wrong way round. So let me pull that out. You need some sort of either a gear or what do you call it? It's basically a spring that lets you connect, lock onto the axle between the spring takes you away. I don't know. Let's plug it in before we. I also have some pliers and some side cutters if you need them. Let's see. I won't use my solder, I will use the partner's solder. So what I'd suggest is figure out how to where the certainly the resistors go first. Right, and then we can figure out the rest. Just going to get that heating up. I'm just going to go wet the sponge of the adapter. Now, one thing I wasn't sure about is the values of the resistors.
I think they have values on the resistance itself. I don't remember exactly what, but I think the fans are just.
They do,
Yeah, the bands, the color bands.
but I don't know which ones are supposed to go where. Oh, there we go, there's it. Oh, there's a picture. Now, do we have the same bands as in that diagram? Does everybody know how to tell the value of a resistor?
I used to guess. I remember looking at it.
We used to have the chart, but it's no longer.
I haven't done that since.
So the top ones there, starting at the top, they're brown, black, orange, gold.
Yeah, there's only the only two of these that have brown.
Right, so brown, black, orange, gold.
Yeah, so those are for
That's
resistors.
1, 0. And then the next, the orange is, I believe, 3. And that says that's 1, 0 by 10 to the 30. Right, so they're 10K. And the gold tells us that it's, I think, 2% or I think. And the other two are red, red, red. Red is 2. So that's 22 by 10 squared, which is, that's interesting, that's 2,200. Right, so we've got a 10k and a 2.2k resistor. And it looks like the 2.2k resistors are R1 and R4, and the 10k are R2 and R3. Yeah, I've got some. So what I'd suggest is soldering the component into position first, and then cutting the leads afterwards. That way they're easier to work with. So have a look at the capacitors, and you should see the polarity of the capacitor written down the side. Haven't actually checked, but yeah, so these ones have a big white stripe with a minus sign on it. And that minus sign it looks like the minus sign has to go on the inside. On this one. It looks like the positive for both capacitors. This one, the positive is on this side, and this one, the positive is on this side. So I'm just going to solder my capacitors in, because I don't have to bend anything, they just slot straight in. And then the other thing we need to figure out is the polarity of the LEDs and the transistors. We'll do that too. Okay. So for the capacitors, that's what I'm doing. I just stick them through and they spring out enough to be held into place. And then what I do, I forgot my solder in this. What I do is you want to heat up the component or the pad. The soldering iron is already hot enough, so you don't usually put the solder on the soldering iron. You put the soldering iron on the place you want to put the solder, and you heat it up, and then you try and melt the solder onto the place where you want it to be. Now, I haven't done much soldering in a long time. I have done a lot of soldering, but it's not something that I do in my day job. I do it as a hobby at home, but it's not. So the LEDs, there's two things. One of them is the one lead is longer than the other.
Yeah.
The other thing is you should see that there's a flat side on one here, one lead, and a rounded side on the other. Sometimes it's a bit hard to see. And that should also tell you the polarity, and I will be quite frank, I do not remember which way round is which. I believe the flat side, yeah, so I can see there's a flat side. I believe the flat side is where the bar at the end of the arrow is, I believe, but we need to look it up before we do anything. Okay, I'm just going to solder my right, so make sure your soldering iron is clean, just by dipping it in on the sponge. The sponge should be wet. I am not doing things quite correctly. The water on that sponge should be distilled water. I just got it from the drinking fountain, so I'm saying this because there's a lab tech I used to work for who would shout at me if I did get arrested. So I'm telling you I'm not doing it properly. And then like I said, in fact, I'm going to get, I think I've got a stand over there. Sometimes it's better to use one of these to hold the piece if you use it. And this one has just got a couple of alligator clips on it, so it should be okay. That way I don't have to use my hands to hold the piece. And then I can just heat up one of the pads and put the solder on there. The iron is hot enough. Now I'm just going to put a little too loose. The iron is hot enough so that it heats it up pretty quickly. Okay. Right, and that's what the signal should be like. It should be on plane, it shouldn't be humped over. Because they're humped over when there's too much solder, right? So that's what the
Okay.
should look like.
And so we should only do a couple pieces at a time, right?
I would only do a couple of pieces at a time, just to get a bit of practice and get everybody able to do stuff amongst it. Now that I've put those in, I'm going to cut the leads off.
Okay.
Okay, so there's my... So if somebody else wants to have a go at one of their pieces, maybe either the resistors or the capacitors, something that isn't polarity sensitive. So, yeah, so that's what I do is, see if you can just put that in there. Yeah, I run this properly. Right, and now, the thing with this is, what I do with these, I bend these out like this, so that they, on the other side, they're lying flat. I usually don't cut it, because I just keep feeding it.
Yeah, for me, I think these two parts to the whole.
That's okay, you do it the way you think. I usually just keep it there, so feed it. So heat up the pad. Yeah, put the soldering iron on the pad, and then put the solder on the pad. Yeah, like that. Yeah. Okay, lift it up. Looks good. So there should be some solder, and you shouldn't be able to see the hole, but it shouldn't fall in place. Okay, understood. Check down there. There you go. Understood. And taking all the way. And if you want to cut those off, cut these off. And so see how it's, you want that side flat down like that in order to get it right down. Alright? And then we'll go through the island and you can start opening the way. But everybody gets to do it.
Now for these, right? Does it matter if this is...
Yeah, so I wouldn't do the transistors yet until I verify the, we can do the print box, they're okay, but I
Alright,
wouldn't do
so I'll
the,
skip this on the bottom.
so just put it in there, and then the whole thing, if I try to push it all the way across, it's a bit more solid. And there, that is like they're in. Right? So grab that little bit there. Now what you need to do is you need to heat up the pad, so you put like the pad to heat it up, and then after a little while it's probably going to heat more than that, because the potential on the computer. Okay, that is perfect. Right? And that's a nice, it's like a nice thing. You just use the same thing for the pad. Do it on the pad, not the lead, so you want it's the pad that's used. Okay, that is it. Okay. Do on the pad. You shouldn't be able to see the hole once you're done.
Yeah, I need to that one, but
Yeah, that's okay. That's okay, and then you got one more to do.
so just one more thing.
Okay? Yeah, that looks good. Let me just take it in. This one. Yeah? Yeah, yeah, that looks good here, so just, basically just wash it.
So it looks good to you?
Yep, that looks good.
Perfect.
Now they're real sturdy.
Okay, so put it in there. Yeah, and
Alright,
wait until I'm doing that, helps them stay flat, otherwise they fall out.
Alright, I'm done.
That's what I was doing.
Oh,
That's
yeah,
okay.
yeah.
That's okay, so we don't get and what we don't touch the silver bit, and we need to touch the pad. Silver thing on the hole on the bottom, and then use that and feed a little bit of that into it. But let it heat up first, then touch the pad rather than yeah. That should heat up pretty quick.
Should have done that in the beginning.
A little bit more. Yeah, that's okay. Doesn't take much, but you don't want to be able to see the whole.
Right, so you can see that.
Yeah, that's good. Try the other side. Well, it's okay, so it's not too much on that one. It's more than the others, but I think it's fine. And then let's see how these are, the big cabinet on the bottom here. You want to get that close to the
Solder.
Yeah, the solder. That's what I can tell you.
And then you said the gold was
Yeah.
the gold on the bottom
It's not
of the resistance. What was that again?
That's the tolerance. It tells you it's within 5% or 10% or 2%. I think gold is 5%.
I'm wondering why the.
Yeah.
Oh, you have
Right.
it backwards.
And then that's soldering out.
I hope not, because I'm not doing so brown and down.
That's what I'm going to pay. Some of that.
I hope it isn't like the thing that's already sufficient for us to know what it is, right? It's just
Does it matter?
it doesn't matter. Yeah. It only matters for us to know what it is. So, I think it was perspective, right? It's a matter of like which perspective.
Yeah, because I'm not looking at the gold on the top.
Yeah.
And then I'm looking at the gold on the bottom.
Yeah. Yeah. Yeah.
That's good.
I think it's soldering on fine to do it off. Soldering. And then just try and feed the soldering continuously. Doesn't take much.
Oh yeah, I think they're all outside today.
I like this resolution, so it's not a nice intention for me.
With the color?
Yeah.
Nothing? Yeah. Okay. And then you want to use this one. Grab it and then see if I can rotate it one and get it close to the place with the noise and stick it in.
This is really fun, actually.
Okay, so yeah, I'm going to go and figure out the LED and transistor, but everything else you should be able to do, because the electrolytics are pretty easy. Now,
You don't need to worry about me.
$210,390.04. Hi. We've got another 15 minutes. We're doing all the power. Where are we usually for power training? I don't mind if you don't mind. On time. You're going to hear drills and stuff like that. Okay, I'll be taking a meeting. Okay, thank you very much. You're welcome. So, the guys who are doing the power are coming in and they're going to be drilling, but we can continue. I don't have anything else to talk about. Just to remember functional resume for next week. And you don't have to finish this today. We can continue it next week. Okay. Okay, it is that way around.
Yeah, good question. What materials are the leads?
What materials?
The leads. Yeah.
That's a good question. I don't know off the top of my head.
Yeah, because I was thinking like if they're the same material as the soldering.
No, they're not the same because
Yeah.
they don't melt anywhere near at the same temperature. It's a coated copper wire.
It's a copper.
Yeah, copper.
Can I see the diamond?
So the emitter is on the right hand side.
I graduated in 2006.
Collector.
And wow,
Graduated high school in 2016. Were you at the open house? The open house room, the building just like the
oh my god.
That's what I'm saying. It seems familiar. I don't know where though.
Well, it's been here for a bit, right?
Mm-hmm.
You might have had a class together, or like you guys were in the same building together, right?
Yeah, most likely.
Good luck. I've met a lot of people, right?
Yeah.
And also, yeah, I remember like freshman year, like using a whole bunch.
Yeah.
Yep, so I've got the two polarity ones, the transistors there.
So these for the stuff, right? So let's say that went to LED symbol, right? It'd be a triangle, right?
Yeah.
And then a line. What's the line be positive?
I believe the line's the negative. Let's just check that.
To the left, right?
Yeah, the line is the negative side, so the positive side is the other side. So in this case, the long lead needs to go to the top of the board.
So we have like 15 minutes left.
Yeah, 15, 20, it's okay. However long it takes, it would be nice to get it done today, but we don't have to.
Also, this came with this comes with oh, it does, yeah. It comes with its own solder.
I do?
Yeah, it came with its own solder.
I don't think mine did. That's interesting.
Oh no.
That's from Kevin.
Never mind. Never mind. That's just because I did.
I'm just going to go to the bathroom. I'll be right back.
So it's okay if we leave these now since we figured it out. The base is in the middle.
Let me just check that I think I did mine right. I just want to make sure that we agree. I think disagree.
Yeah, that's exactly how I got it too.
Oh, so you've got those two.
So if you want
I've got them both in the same direction.
in the same direction.
Right, because it's both collector, base, emitter in that order. So I think they've got to be both going in the same direction.
The hoses are like a capacitor like so low, right?
So there's no...
The whole machine is a capacitor so close to full, right?
No, not at all. No, that's a bit your polarity.
Yeah, got it.
So you've got your transistors. So let's not do any transistors until we agree on the polarity of the transistors.
So don't do these.
Okay, so I have. So this is the polarity that I can see. I think we're okay with the LED. Let me see if I can do that down. There we go. Right, so if you've got the flat side facing you, the right hand pin is the collector. Right? So if you've got the flat side facing you, then the right hand pin, your right hand pin is the collector.
Yeah.
And then the middle one is the base, and then the emitter is the collector. So I think that so I think that's right. So do you agree with me, or do you think this is... So I have
Actually, can you just that so it has to be on the right hand side, right? Or because it looks like these are flipped.
Right, but the ordering of the pins still stays emitter. Sorry, is still collector space emitter. Right? Collector space emitter. Right, I think they've still got the same
regardless of which orientation.
yeah. The white is split now, but the order is still the same. Collector space emitter.
What's the point of flux? Not to remove it?
So flux is to bring up the board. I decided 80% flux at home, but I decided not to bring it in. Its aim is to clean up the board before you put the soil.
When I see people do this, I don't see them.
It should be, that's another thing that but I thought when things are all brand new and it's not a critical piece of circuitry, we can turn it on something. Chuck, do you have the file?
I think yes.
Maybe the covers. There's another book.
We started the battery type 2, right?
Yep, got to solder the battery pack on, and red is positive and black is negative. So the top two.
For the lights, the smaller one is negative.
Right.
So I want to put it like this. So I put it up top.
The top is positive, the bottom is negative.
Because of the line.
Yeah.
See that flat line?
Yeah.
Up this way. I don't know. You have like, you have have
Yep,
I just like to extend it a little bit. It seems so good.
What do you want to do?
Extend it.
You mean
Yeah.
cut some more of that off? Yeah, I usually. Oh, just do that.
Yeah, that's perfect.
Same as that one?
That's perfect one,
Good.
yeah. I think so.
You need to solder in before you start. Some solder on the walls before you.
Okay.
Okay.
Will do.
You need the runner or
You can get that out easily now.
double A battery.
What?
Double A battery, and that's it. And then, so what are the lights going to be? Turn on and off?
They should just alternately turn on and off.
Okay, between the two.
Yep.
And this is just very basic lights. But we're going to be doing much bigger stuff, right?
Maybe. It depends on what they decide to do. Right?
Yeah.
I just last semester I found people had never soldered before and they needed to.
Yeah.
The home security drones are to wire up all their motors and everything and solder it up, and they hadn't soldered before, so I had to show them how to do that.
You ever built an 8-bit PC or 4-bit?
Yeah, I built a little C80 system right back in high school years and years ago.
Yeah. I wonder if building it now would be better.
Possibly.